Assalamualaikum and a very good day to everyone. We are Group CNC and today we will present our project titled The Making of Traditional Gasing using CNC Turning. So introducing our team members, Muhammad FIRDAUS ZAHARI, Muhammad SYAFIUDDIN bin KHAIRUSSALIH, Siti Nur IWANI binti HANAFI, YUVENISHWARY anak perempuan R. MAGASUARAN, and also myself, Muhammad NABEEL HAKIMIE bin ZUNAIDI. So we move to the next page. The CNC stands for Computer Numerical Control. It is a machining process where the tools are controlled by using computer code, mainly using a G code to perform accurate and consistent cutting operations. CNC is widely used in industries such as aerospace, automotive, medical field due to its precision, repeatability, and efficiency. For our project, we choose to manufacture a gasing that is a traditional Malaysian spinning top. The gasing is a cultural symbol that has been used for generations, especially in rural communities, and as a game and a form of entertainment. Traditionally, gasing is a handmade from a wood and using a basic tools and skill by a craftsmanship. However, this manual process can be inconsistent in shape, balance, and size, which can affect how well the gasing spins. By using the CNC turning, we aim to modernize the production process while still keep the traditional shape and the function of the gasing itself. This project shows how we can preserve cultural heritage while improving the product quality through the modern technology.
Next, we move on to the methodology of our project programming process. The first step we took was to design the casing according to the size of the raw material provided. Once the design was finalized, we created a CAD drawing to clearly show all the dimensions. Before starting the programming, we identify the tools, G codes and M codes needed for the process. For tooling, we use a roughing tool and a left plunge tool for the initial cutting. For finishing, we use two types of tools, a right finishing tool and a neutral finishing tool. In the header of our CNC program, we use 5 main G codes. G18 is used to select the Z-X plane, where Z represents the length and X represents the diameter of the material. G54 is used to set the datum or offset point. G71 set the metric format since our dimensions are all in millimeters. G90 enables absolute positioning and G95 set feet per revolution, which is suitable for CNC lathe operations. For the cutting process, we use G00 for rapid positioning, that usually for safety position, G01 for linear cutting, G02 for clockwise cutting, G03 for counterclockwise cutting. We also apply several M codes in the program. M00 to stop the program, usually used before a tool change. M06 is the tool change command, and the M04 is used to rotate the spindle counterclockwise, which is standard for lathe machines. Finally, M30 is used to end the programming. As the for cutting parameters, we use a fit rate of 0.1 for normal cuts and 0.5 for angle cuts. The spindle speed throughout the program was set to 1500 RPM. This slide shows the coding we generate.
After completing the program in the Sinutrains and numeric simulation, we transferred the data to the CNC lathe machine. We then verified that the tools used in the simulation matched the actual tools on the machine. Before running the program, we did the final check on the code and ensured the feed rate and spindle speed were suitable initially. We set the feed rate to 0.1 for straight cut and 0.05 for angle cuts, with a spindle speed of 1500 RPM. However, we adjust this setting during machining based on a real-time condition. Next, we set up the workpiece by clamping about 30 mm of materials to ensure it remains stable during the process. The first stage was a roughing stage, where we use a control cutting method. Since the roughing tool couldn't reach the shallow middle section of the workpiece, we only performed a straight cut in the area. We also reserved a 0.25 of material for the finishing process. Then we move on to the plunge cutting stage. In this step, we use a left plunge cutter to remove the shallow section in the middle using plunge turning. Although we initially planned to use grooving, the lab assistant recommended us to plunge turning instead to save times. Again, we reserved 0.25 mm of materials for the finishing stage. The final stage was finishing. For this, we used two tools, a normal finishing tool and a neutral tool. The neutral tool was necessary because certain areas of the workpiece couldn't be reached by the normal tools. After completing all the stages, our gasing product was successfully finished. Here are the results of our project at each stage. The first stage is the roughing process, followed by the plunge stage, which is used to cut the shallow section in the middle of the workpiece. Finally, we move on to the finishing stage. This image shows the final product of our complete gasing.
Let's move to this discussion part, focusing on surface finish and dimensional accuracy during machining. We encounter two main issues that affected the quality of the machining part. As you can see, the surface finish was not smooth and the dimension was not consistent with the drawing. For the first problem was use of the wrong machining method and an unsuitable cutting tool. During machining process, we use plunge cutter tool. As we know, plunge cutter tool are used for grooving process, which is designed for cutting straight groove, axial feeding, Z-axis, and not for counter for X-axis. This leads to poor surface quality and the dimensions are not accurate. From that, for our suggestion is switching to a more suitable cutting tool, which is double and insert with a V shape, which provide better tool to cutting at a part, also give a stability and finishing quality. The second issue was tool wear and improperly machine setup. This is because so many people use that machine, the tool got wear and the machine was not perfectly aligned. Maybe the person before changed the tool or the machine shut down for maintenance. To overcome this, the machine needs to calibrate properly before use to ensure working correctly and producing accurate high quality part from the start, and need to monitor the cutting tool condition more closely. By addressing both tool selection and machining calibration, we were able to improve the surface finish and achieve better dimensional accuracy, also ensuring the final product meet the design requirement.
In conclusion, this project shows how CNC turning can be used to make a traditional gasing with the high accuracy. The final product was made successfully with the right shape, balance, size, and surface finish. This proved the theory and hands-on skill were used well together. The CNC program created by senior trained numeric worked properly and helped the lathe machine follow the design. Some of the small error in the size about 0.3 to 0.6 happened, which is normal because of the tool wear, machine movement, and setup issue. The plunge cutting and the surface finish that were a bit challenge, showing the need for the right tool and method. Even with this small issue, the project reached its goal. It also shows how a traditional item like the gasing can be made better using modern technology. This project is a good example of how engineering can help preserve cultural heritage through careful planning and accurate machining. That's all for our group. Thank you for listening.